Okay, this first question is from the Educate papers, Sample 1, Paper 2, Section B, Context and Applications, and it's question 7. And the question reads, the blood pressure chart below shows the normal blood pressure of healthy adults. Blood pressure is a way of measuring the amount of force exerted on the walls of blood vessels. A person's blood pressure, P, is measured using two numbers, the systolic pressure and the diastolic pressure. And in the chart you can see the systolic pressure, blood pressure in millimetres of mercury, 140 from 90 to 140, and the diastolic blood pressure in millimetres of mercury from 60 to 90. I'm going to leave out part A, and I'll come back to that in a tutorial in the future, and I'll go through it. It's on the normal distribution. So moving on to part B. The following are well-known statements concerning the relative frequencies of strokes and high blood pressure. S is the percentage of the population aged 70 who have had their first stroke before 75. H is the percentage of the population who have high blood pressure at 70. Let SC represent the percentage of the population aged 70 who do not have a first stroke before 75, and HC as the percentage of the population who do not have high blood pressure at 70. Convert the following into probability statements. Part 1. 10% of people aged 70 will suffer a first stroke before 75. Okay, so starting off, so the probability of a stroke is equal to 10 all over 100, which is now 0.1. Okay, so that's part 1. 10% of the people aged 70 will suffer a stroke, the first stroke before 75. So the probability of a stroke is 10 over 100, which is 0.1. Of those who had their first stroke within 5 years of turning 70, 40% had high blood pressure at age 70. Now with this question, of those who had their first stroke within 5 years of turning 70, at this point here, look for conditional probability. Who have had their first stroke. Okay, so it's given that they've had a stroke within 5 years of turning 70, and 40% of them had high blood pressure. So with this, it's the probability of high blood pressure given that we already know that they've had a stroke. So that's going to be 0.4, or 40 over 100, which is 0.4. Now, of those who did not have their first stroke within 5 years of turning 70, 20% had high blood pressure at age 70. Okay, so who did not? So once again, we've been given a statement. We've been told that they did not have their first stroke within 5 years. Now, from the start of the question, we were told that SC represents the percentage of the population aged 70 who do not have their first stroke before 75. Now, so what we're given here is we're given information referring to SC, those who do not have their first stroke within 5 years of turning 70. So we've been given those who did not have their first stroke, and we're told that 20% of them had high blood pressure. So it's the probability of high blood pressure given that we know that they did not have a stroke within 5 years of turning 70. Okay, and that is 0.2, or it's 20 over 100, which is 0.2. Now, the next part of the question, part C, is write down the formula connecting. So it's the probability of stroke given high blood pressure, and you're linking that with the probability of high blood pressure intersection stroke. So that's high blood pressure and having a stroke, and also then the probability of high blood pressure. Okay, so we're in conditional probability here. So we have the probability of a stroke given that they have high blood pressure. Okay, so our formula is the probability of stroke intersection high blood pressure, which is a stroke and high blood pressure, divided by the probability of what you were given. You already know that they had high blood pressure. And so that's your formula for your conditional probability. Now just note there also that stroke intersection high blood pressure is the exact same thing as the probability of high blood pressure intersection stroke. Okay? Now in part D of the question, fill in the boxes in the tree diagram and write down the 4 probabilities to the right of the diagram. Okay, so the tree diagram here, so we've just, at the start, okay, so we're told that point 1 is the probability of having a stroke, and just referring back to the question again, having a stroke, age 70, who have their first stroke before 75 years of age, okay, so a good idea would be just to kind of write that out to the side. So these are the people aged 70 and have a stroke before age 75. Okay, so we know that that probability is 0.1, so therefore the probability of being aged 70 and having no stroke before the age of 75 is SC. Okay, so just again, so this is aged 70 and no stroke before 75. Okay, so one probability is 0.1. Remember, probability goes from being from 0 to 1, so we have 0.1, so this has to be 0.9. 1 take away 0.1, which is 0.9. Now, so moving on to this branch of the tree. So this is then the probability of high blood pressure, given that we already know that they've had a stroke, okay? Of high blood pressure, given that we already know that they've had a stroke. Now, if you just move back up to B part 2 of the question, this is high blood pressure, given that they've already had a stroke, is 0.4. So that's our value for in here. Okay, so just to recap, when you're reading the tree diagram, so reading from here out, so you're in conditional probability again. So it's the probability of high blood pressure given that they've had a stroke. So that's 0.4. Okay, so the probability of no high blood pressure given they've had a stroke is going to be 1 minus 0.4, which is 0.6. Now, down to the bottom of the tree diagram, so we have the probability of being age 70 and no stroke before 75. So that's given to us at the moment. So it's the probability of high blood pressure given that they're age 70 and have had no stroke before 75 years of age, okay? And if you move up to B part 3 of the question, we've already gotten this value, the probability of high blood pressure given that they've been age 70 and no stroke before the age of 75, so that is 0.2. So it's going to be your 0.2. So therefore the probability of no high blood pressure and no stroke before the age of 75 is going to be 1 minus 0.2, which is going to be 0.8. So to the end of it, which is the probability of stroke and high blood pressure. So we have stroke and high blood pressure, which is 0.1 by 0.4, which is 0.04. That's our probability of stroke and high blood pressure. The probability of stroke and no high blood pressure, so if we follow the branch, it's 0.1 by 0.6. By 0.6, which is 0.06. Now, if we follow the branch down here, the probability of being age 70 and no stroke before age 75 and having high blood pressure is going to be 0.9 by 0.2, which is 0.18. And the bottom branch of the tree diagram is the probability of being age 70 and no stroke before 75 and having no high blood pressure, which is going to be 0.9 by 0.8. 0.9 multiplied by 0.8, which is 0.72. Now, on to part E of the question. From the tree diagram, find the probability of high blood pressure. So, definitely valuable to look back at your tree diagram, have your tree diagram beside you. So you're looking for the probability of high blood pressure. So from your tree diagram, you can just bring it back into view again. From your tree diagram, you're talking about probability of high blood pressure. So it is the probability of stroke and high blood pressure, and the probability of 870 and no stroke and high blood pressure. So it's 0.04 plus 0.18. So the probability of high blood pressure is the probability of stroke and high blood pressure, or you could have the probability of being 870 and no stroke and having high blood pressure. So that is 0.04 plus, because we're talking about or, 0.18. And that gives us a value of 0.22. Now, part F of the question, hence find the probability of stroke given high blood pressure. That is the probability of a person suffering a stroke between 70 and 75, given that he had high blood pressure at 70. Okay, given that he had high blood pressure at 70. So we have probability of stroke given high blood pressure is the probability of stroke and high blood pressure divided by the probability of high blood pressure. Now we already know that from our tree diagram that the probability of stroke and high blood pressure is 0.04 divided by the probability of high blood pressure, which we're after finding above in part E, is 0.22. And 0.04 divided by 0.22 is 0.182. So that is the probability of a stroke given that the individual has high blood pressure. Now to part G of the question. Find the probability that at least 2 people in a random sample of 10, so I'm circling 10, 70-year-olds with high blood pressure will have a stroke within 5 years. Give your answer correct 2 decimal places. Okay, so hopefully you've recognised that this is a Bernoulli trial. Because you're given that there's a number of times the number of trials is 10. Okay, so you're told at least 2 people in a random sample of 10 70-year-olds with high blood pressure will have a stroke within 5 years. Okay, so we know that the probability of having a stroke, we know the probability of having a stroke, and in the question you're told that the people having a stroke, given that they've high blood pressure or with high blood pressure, so you found that in part F above, is 0.182. So the probability of not having a stroke is going to be 1 minus 0.182. So 1 minus 0.182, which is 0.818. Now remember, with a Bernoulli trial, you've got to identify your success and your failure. A success, in this case, is having a stroke, and a failure is not having a stroke. So your success is having a stroke, and a failure is not having a stroke. Now, so because we're talking about at least 2 people in a random sample, at least 2 people will have a stroke. So we've got to look at, it's going to be 1 minus the probability of no one having a stroke. So none of the individuals having a stroke. And also we've got to look at, So it's or. We've got to look at the probability of one of them having a stroke. So one having a stroke. Okay, so it's going to be 1 minus, now there's 10 random people being chosen, so it's 10, and our success is having a stroke. So if none of them have a stroke, so we have no successes. So it's 10 choosing 0, and our success is going to be 0.182 to the power of 0 by our failure, which is having a stroke, is 0.818 to the power of 10. Plus, then one of them having a stroke, so it's 10 choose 1 by 0.182 to the power of 1 by 0.818 to the power of 9. And just recapping, where did I get my 9? 10 minus 1. Okay, so when I do that out, I get 1 minus 0.134132 plus 0.298435,938. So that's going to be 1 minus 0.4325,68134. You can round, but I wouldn't round any more than off to 3 decimal places. So that's going to be 0.567, and in the question we were asked to 2 decimal places, so 0.57.